Many of you have been automating your networks for years. Those Python scripts that you've written to check interfaces, get routes, and verify ACLs have come in handy. And some of you have even figured out how to create a central source of truth for your network. But what if you could use your natural language to query and gain insights from that source of truth about your network? So rather than developers and DevOps engineers opening tickets and reaching out to you directly to ask questions about routes, ACLs, NATs, and DNS, they can simply query a chatbot. And I'll take it one step further. What if you could have an agent that understands your network and can take action, but not in the traditional if this, then that approach, but can actually think through, plan, and execute on that plan with the level of intelligence of an experienced network engineer? This is the ultimate network agent, and this is where I think the industry is going. Let's get started. Now, today, we're going to talk about the AI hype. From there, we'll discuss the evolution of network management. After that, we'll go ahead and build our own AI network agent. From there, we'll discuss the real-world impact. And lastly, we'll close it out with the road ahead. I'll have all of the slides and the code available for you to download. I created a static site, just scan the QR code at the end, and everything will be available. Now, let's talk about the elephant in the room. AI fatigue. How many of you are tired of seeing AI-generated images, AI-generated LinkedIn posts, and hearing about the next great AI product? I understand. I'm not here to market you. I'm not here to sell anything to you. I'm not here to talk about the hype. I'm just here to talk about the things I learned and to help you think about the future, because the future is here right now. Now, there's some myths we actually need to talk about. The first one, AI will replace network engineers. I think we heard the same thing about network automation, right? That's not going to happen. All of your expertise, whether you're an expert, professional, associate, just getting started, that domain knowledge that you have as a network engineer is relevant. We're still connecting things. Whether it's at layer 3 or layer 7, your knowledge is still relevant. The next myth, AI will solve all network engineering problems. No, this is not the case. It does some things really well, like analyzing data, summarizing texts. It's really good at that stuff. Writing code is getting even better at that. But when it comes to solving all our problems, we still need a human in the loop. Your skills are still very valid. Now, the next hype is around AI-powered, fully autonomous networks. We're not there yet. Now, there are some things that are kind of AI-powered and fully autonomous, but entire networks, they're probably automated. There's probably some AI involved, but there's still humans in the loop. The last one is all about that AI hype in networking. Is it hype? No, it's a real thing. It's a real thing, and we'll talk about that here today. Now, this is some facts that I want to kind of discuss from an OpenAI paper on the labor force, because I kind of want to level set so everybody can kind of think differently. This paper estimates that 80% of workers belong to an occupation with at least 10% of its tasks exposed to LLMs, while 19% of workers are in an occupation where over half of their tasks as labeled as exposed. If you think about your jobs, how much of your job is routine? I do this every day. I look at this task. I look at this data. And it really could be automated. The decision isn't too complex. All of that is probably exposed to an LLM. So it can either assist you or it can replace the task. Another thing that kind of got us here and why we're having this conversation is that 93% of companies believe AI will be a game changer in driving growth and innovation in the sector. This is a real report. How many of you are in an organization that has either rolled out AI or talked about AI? Whether it's an MVP, whether it's a chatbot, whether it's how can we use this? It's affecting us all. Now, but why? November 2022, ChatGPT was announced. In the first 5 days, it had 1 million users, fastest app ever to do that. In 2 months, you know how many users it had? 100 million in 2 months. I started using it in January 2023. I've seen it evolve. A lot of the challenges and problems that I had with it generating code, with helping me solve problems, I don't even think about that getting into my way now. I'm a network engineer that loves Python, but the problem with my code has always been front end. I built this great tool. I use Flash to get an API, but the front end, it looks horrible. Not usable, I can't roll it out. Generative AI is helping me generate that code today so I can get a real valuable MVP and scale it out to my team. But what is it? Let's actually talk about it. So we're going to break it down. What is generative AI? Generative AI is a subset of machine learning. You take a prompt, you pass it to the model, it's able to generate text, videos, pictures, music. It can summarize blog posts. It can do a bunch of amazing things with data. Here's an example of me giving it a prompt asking James Bond moonwalking on a beach in an animation style, and it generated an image. Think about that. It took about, 20 seconds to get this image. Something simple. Now, where does generative AI kind of fit? AI has been around since the 50s, and it's evolved into machine learning. In 2010, Google started doing deep learning with neural nets. And in 2017, there's a paper called Attention is All You Need, which introduced the transformer network, which now led to generative AI as we know it. This has been moving fast, but it's been progressive over a long time. How does it work? At the foundation, you have something called, as many of you know it, a large language model. We call it at AWS a foundation model. The way this model is created or pre-trained or trained is based on a large corpus of data. It's known to be all of the publicly available data on the internet were used to train or pre-train these models. From there, it's able to understand this data to adapt to different tasks. Now, when you use tools like ChatGPT, it has been post-trained to be a helpful assistant to answer your question, to do things like generate code, summarize your blogs, help generate configurations, and all of those good things. But how can we use it in networking? Well, some great use cases is around generating configuration. One way I use it, I write my Python code. I don't really like documenting my code or writing readmes. I take all my code, I dump it into a large language model, tell it to generate me a readme. Now, do I take it and post it on GitHub? No, I analyze it and read it myself. I put my human in and I get it done, right? But it's helping me iterate faster. In production, it's being used. Teams are trying to figure out how to use things like retrieval augmented generation on their documentation so they can help scale and get information faster. It's being used. It's real technology. Some of us think it's a hype, which it could be. What it looks like today, it will not look like tomorrow. I truly believe that. But it's the beginning of some great technology. And I mentioned great, but there's some real challenges. Some of those challenges are around, it does not understand your internal network configuration, your infrastructure, your IP addressing scheme. It has no awareness of that. It has no awareness of time and date. It has no awareness of the weather unless you give it that capability. Another challenge is around privacy and security. Privacy and security of your data that goes into the model. If you're using a model in a public provider, you need to read their terms and conditions. You also need to understand the privacy and security of the model, whether you're running it on-prem or in a provider. Another challenge is around hallucinations. The model sometimes makes up things. There's a lot of white papers and there are a lot of smart people trying to solve this problem, but it does happen. But it's improved. It's improved greatly. But what does that mean for networking? I think it's important that we actually look at networking when it comes to network management over time. For about 30 years, we've been doing network management kind of the same way. In the 1990s, SSH was introduced. And then in 2010, something interesting happened. Software-defined networking, which led to the explosion of APIs, which led to automation, which is why we're all here. And then in 2020, we started hearing terms like intent-based networking, self-healing networks, and now we're trying to use generative AI. So this has been a progression. And if I'm being honest, when I first seen generative AI, I said, yeah, this only makes sense. Because when I write my Python scripts for my infrastructure, I'm doing if this, then that. And I had to think about that. I got to be the one to actually think about the use cases and the problems that need to be solved. AI could actually think and make intelligent decisions without me having the right conditions. And I'll show you. I build the tools and let the AI decide which tool to use. So how do we evolve to this? What are some of the challenges we're facing? Well, one is around the scale. The data center's kind of always been the center, but now we have these branch offices. We have LANs, MANs, WANs, and then hybrid connectivity to the cloud. Some of you may be cloud native, but either way, whether you're at layer 3, layer 7, now there's application layer networking that we also had to think about. Which leads to new routing challenges, security challenges, performance challenges, and also cost considerations that we also had to think about. So if we were actually to build out a network agent, what would it look like? Well, the first thing we need to do is define what an agent is. Here's how I define an agent. When it comes to an agent, when you ask let's say ChatGPT a question, you ask it a question, it gives you a response. Now, when it comes to an agent, you ask it a question, it thinks about that question and decides if it needs to use a tool. It talks to itself to say, okay, I need to use this tool. It goes out, uses the tool, the response comes back, it decides, okay, I need to take this action, and it goes to this workflow till it actually solves the problem. That is an agent. Think of you as a network engineer. You're an agent. Your tools could be the tools that you use in your job to solve a problem. You can build the same thing when it comes to AI and networking. Now, there are some requirements that we need to think about for an agent. The first thing we need to think about, of course, is going to be the use case. You all can take your time and define whatever use case you want to start with. I recommend starting small. The next thing we need to think about is the model. Are we going to have a model on-prem, or are we going to have a model in the cloud? If you have a model on-prem, great. It works great on my computer, but does it scale? Who's going to support it? Do you really have expertise when things go wrong? Do you actually know what's happening? Are you logging things that go in? Are you logging things that come out? Are you putting guardrails around this model? So maybe you want to go to the cloud. So once you kind of determine all that, then you want to think about what are some things we need to have? What are some must-haves we need for our agent? First, if you don't have a source of truth, you need to centralize and create a source of truth, because this is what the agent is going to use. The next thing we need to think about is the telemetry data. You may want to use that and feed that in as well. And then access to our documentation for our organization. Now, some should-haves. Well, when you build this agent, it can actually be API-driven and event-driven. It doesn't have front-end, some type of natural language processing. It doesn't have to have a front-end. It could just be API-driven. And we'll talk more about that here in a moment. The next thing we need to think about is the historical data. It may need to access some previous data in order to make intelligent decisions. You may want to integrate it with your ticketing system and then have some type of approval workflow with some type of human in the loop. Now, some nice to haves. Many of you can solve a lot with prompt engineering in RAG, or retrieval augmented generation. But you may have to fine tune a model. But that's not as easy as taking a whole bunch of data and dumping it into a data source and say we're using RAG. You're going to find out that's very hard. And when it comes to fine tuning, you also have to label your data. And you're going to find out that's very hard. But it can be done. The next thing you want to think about is some advanced analytics that you may want to receive, as well as some custom dashboards. Now, the last thing I want to talk about here is going to be the key risk and considerations that we need to think about. First is the data sensitivity. The data that goes into the model, we need to verify what goes into the model, what comes out of the model. Maybe you want to block some data that goes into the model or comes out the model. Maybe you want to mask some IP addresses or passwords or account numbers that go into the model and come out of the model. These are all things we kind of need to think about. We also need to understand the compliance. Can I use an on-prem model? Do I have to use an on-prem model? Can I go to the cloud? The next thing is, who should access the agent and what should the agent have access to? These are some of the risks and considerations we have to think about. In the skills gap. There's a skills gap in networking, there's a skills gap in automation, and I'm sure there's an even bigger skills gap when it comes to AI in networking. Now, I kind of talked about this, but I didn't say it out loud. Data quality. Bad data in, bad data out. Documentation in networking is a problem. If you take that bad documentation and you try to use it, you're going to get bad results. So you're going to have to make sure your documentation is updated. These are some things you have to think about. The model can actually help you with your documentation. We don't have to do it the hard way. We can have AI kind of help us with the documentation, use humans to analyze the documentation, ensure it's correct, and then we can use it. Now, when I think about an agent, there's a particular architecture and approach that I go. The network layer, the AI layer, the API integration layer, and the user interface layer. We're going to break each of these down. The networking layer. If you don't have a source of truth, this is where you got workers going out gathering information about your network. Your metrics data, gathering that. Your event data, your documentation, you're gathering that. And then you have some type of ingestion or data processing pipeline. And then you're sanitizing that data, and then you're loading it into your data source, so that way it can be consumable for your agents as well as your organization. And so it'll look like this. Once you achieve this networking layer, this is the foundation for the tools that you'll be building. Now you start building that AI layer. You've determined a model. When you determine this model, you're going to have to do some type of evaluation. What are the use cases you're going to solve and you're working to solve or you want to solve? Test the model. Ask questions against existing models to see which model can kind of get you there now. It doesn't have to be the most expensive model. You can find a cheaper, lighter model that may have great results, but there needs to be some type of evaluation. This is where the education to bridge that skills gap comes in when it comes to generative AI. Now, once you decide on the model, the next thing you want to start doing is building out tools. This is where you're going to start building out your RAG or retrieval augmented generation pipelines so you can access the information in those knowledge bases or in those data stores that you have. And then you're going to, since you're all doing network automation now, you already have Python scripts. Those are tools for agents. And so to get the metrics, get the routes, these are all going to be tools that you can add to your agent. Now, these tools come from Python scripts. They can access APIs, they can access databases. You design this, you architect it. But on AWS, you can also use something called Bedrock's agents, where we kind of orchestrate that workflow for you. You create Lambda functions, and then those Lambda functions are orchestrated in Bedrock. We handle that. The example that I'm going to show you, the code sample that I'm going to show you, everything is orchestrated by you. It's all in the code. So you can actually see this process. Now what this actually looks like once you put this together, when I talk about the orchestration, here's a query. How many VPCs do I have in US East 1? The network agent then decides which tool to use. It has memory of the full conversation. Remember that it's talking to itself. So it's saying, okay, I need to use this tool. What that really is the agent responding back to say I need to use this tool. And within my Python code, I go execute the tool and then tell the agent the results of that tool being used. And so now the agent can look at those results and process a response. The agent really doesn't have access to tools. It just knows the tools are available. But you, as the network developer or network engineer, are the one that does the orchestration. And then when you're building this out, you may use one model, but you may use multiple models where you have one model that kind of thinks, okay, how do I plan this? What agents do I need to use? How do I evaluate this? How do I test this? And then I generate my response. And so here's a code sample of some Python scripts that I had to just list things like the VPC, check for internet gateways, and these are actually tools that I actually pass to the model. And so here's an example of my handle tool use, where I list all my tools so the model knows what tools it has available. And here's another example for get interface metrics. Now, the next layer is taking our AI layer or our AI agent and then building an API around it. This API is going to allow us to be able to leverage it via front end as well as other tools and events within our organization. This makes it more consumable across the board because the developers may need to use this tool. You, as network engineers and NetOps, may need to use this tool. So here we can actually do authentication check, create permissions, handle the routing, rate limit, and do everything we need for our agent to be consumable. And what I want to show you now is what an API looks like when you're talking to a model that has tools available. Here we're using the Converse API on Amazon Bedrock. What this allows us to do is be able to use a conversation with different models and handle those conversations all in one API call. It also gives us the ability to use tools. So if you look, we pass in the model ID. In this example, we're using Cloud 3 Haiku, which is the lightest and fastest model by Anthropic. And then we have a messages array that we're passing in. If you talk to a model through an API call, I ask a question, get a response. If I don't handle that conversation and pass it back to the model, it will have no understanding of the previous conversation we just had. So what this messages array does is as I'm having a conversation with a model, I'm passing the entire conversation into the model so it can have a full context of our history of our conversation. Next is the system message. Now, this is where you actually give the model the behavior or the role that you want it to have. You also tell it the abilities that it can do and the abilities that it cannot do. Next is going to be the hyperparameters. For example, the temperature. The temperature controls how predictable the responses are. And then after that, we're passing in all of our tools that we have available to the model so to know what tools it has available. Now, this user interface layer. As a network engineer, I built a ton of tools, centralized them in a Docker container, and everybody accessed it via CLI, just because I couldn't build a front end. That's one approach. I don't know how scalable it is, but it worked for our team, right? The next approach is to use something like Streamlit. When you download the code, I use Streamlit. This is a Python library that makes it really easy to spin up a front end so you can test out, build, and share your generative AI applications. And something I mentioned is that with generative AI, you can actually build your own front end. And I do this a lot now. I have generative AI build out the front ends that I need, whether it's with HTML, React, or some other language. Now, let's actually see our network agent in action. Here's a basic network query to any foundation model or large language model, any chatbot. Here we're using the chat in Amazon Bedrock. This has no tools abilities. I ask the question, how many VPCs do I have in this region? Cloud says, I apologize. I don't have access to the specific AWS account or region. That's what we expected to say. No hallucination. It doesn't have access to my particular region. This is what we expect. Now, Let's actually give it tools abilities. This time I asked it, what tools do you have available? Cloud uses the list function tools, and it's able to tell me all the tools that it has available with the description of the tools that it has available. Now we're getting into our agent. Let's go ahead and ask a question. How many VPCs do I have in this region? Notice that Cloud uses the list VPC tool and then provides us a response that says, based on the output, there are 4 VPCs in US West 2. We hop into the AWS console, and there are 4 VPCs in that particular region. This was with the tool. The agent was able to make the API call, analyze it, and give us a response. That's pretty simple. We've seen that before. But what does a complex query look like? This time it's going to have to do something way more complex. We're going to ask it to find what region this particular VPC is in, and then determine if that VPC has internet connectivity. Those of you that understand AWS know that first, it has to know all the regions that are AWS. It had to scan those regions to see if that VPC is in that region. Then it has to understand if that VPC has an internet gateway attached. This is how it actually looks. I asked the question. Notice the response from Clyde. It's thinking. Let's use the tools provided to find the information you need about that VPC. This is an agent at work. Now it's planning. First, I'll use the check internet gateway tool. The next plan. Now I'll determine the region the VPC is in, and I'll use the list VPC tool. So it thinks about it, it decides, I'm going to use these 2 tools to give you an answer. And here we get a response from the foundation model with the VPC is in US West 2, and it determines that it has internet connectivity through an attached internet gateway. This is an agent. We hop in the AWS console, look at the resource map in the VPC console, and we notice that that VPC is in US West 2, and it does have an internet gateway attached. To take it a step further, what I could do is have it check security groups, network access control lists, and all these things, but it solves the problem. It answers the question. So what's the real world impact of where we are now? Now, I get it. You're network engineers. You're skeptical. I understand. When we think about this, we need to think about what's low return and what's high return. There's a Goldilocks zone. You see that green circle? This is where you want to be. In this boost zone, you're finding those use cases that are low risk but high enough reward for you to actually get benefit for your organization. In that same green circle, that learning zone is where you're experimenting. You're finding more complex use cases. You're putting those MVPs out. You're testing them to see if you actually get a higher return to help your team. Now there's a danger zone. You go too far to the right, and now you're in use cases where the risk is just too high. This is some things you need to think about when you start developing these use cases. And so some considerations we need to think about when we start talking about agents is going to be around what I've kind of discussed before. But this isn't as easy as I'm making it sound, right? Because we want to scale, we need tests, but if you're doing automation, you probably have unit tests. You probably have some integration tests. Your agent should not access your network. It should talk to the source of truth, and if it's going to take action, you probably want to have some type of pipeline that has those actions being applied rather than the agent actually going out and do the thing, right? Because how do you automate now? You're using probably some CI/CD, maybe. If not, maybe you're just writing your Python scripts and you're executing them in production, no tests. We're living YOLO. I don't know. It depends. But those are some of the things you got to think about. We also need to think about when we're testing these models, we're evaluating for things like bias. Does it really solve your problem? These are some of the considerations that we all need to be thinking about when we're testing these models. And I mentioned some of these before. So the road ahead, what does it look like? We should start small. Just like automation, start small, get some knowledge, build a foundation, get an understanding of what it can do, what it can't do, and then go from there. Once you understand the capabilities, maybe even work with developers and data scientists to really help scale your solutions. Like I mentioned, RAG is hard. It sounds good in theory, but the data quality, the data engineering is a real thing that needs to be applied when you're using RAG. The next thing we need to focus on are fundamentals. Your networking knowledge is more valuable than ever. We really have to continue to learn that, continue to scale that. The enhanced AI capabilities, once you start experimenting, build some MVPs with some natural language processing and some front ends, and then get them tested within your organization. Leverage things like RAG, and if you really need to, try to fine tune. Now, collaboration. This is where I have a question for you all. How many of you are mentors? When I look around this room, everybody take a look around the room. I've been mentored by many people that look like you, and I'm extremely grateful, thankful, I have great relationships with them. But this industry is evolving, it's getting older. Diversity isn't about gender and race, it's also about age. I want to challenge each of you to think about mentorship. Get uncomfortable. When we come back next year, let's have the same conversation. Because this industry needs more people that are experienced in networking, regardless of what they look like, where they're from, and what their age is. And so, this completes my presentation, but I have one more thing I want you to think about. AI is not going to replace humans, but humans with AI are going to replace humans without AI. The same kind of applies to network automation. I just thought it was cool and I'll put it in here. But I really do believe this is true. I thank you all for joining me today. Feel free to download the presentation and code, and I'll see you next year. Any questions?
I just did a little experiment with AI, and I'd been introduced to agents last week. I'd been introduced to agents in a class last week, and I was kind of blown away. You can give the model via an agent access to a database, and then you can ask it things like, who had the biggest sales. And I wanted to have that sort of dialogue with an agent about my network. And I started out wanting to give it all my interface statistics. And so I let it calculate the tokens of one extensive output, and then I told it how many switches and interfaces I had, and it said I could hold about 7.5 minutes of your data in context. So I couldn't really have a historical dialogue looking back 30, 60, or 90 days. So I wonder, with that in mind, what strategies do you have for, sort of having a long view of your network data and getting the kind of answers we generally want about trends and these types of things?
Yeah, so one thing I didn't talk about was traditional machine learning. Generative AI isn't the only solution. And so you may have to evaluate that with some traditional machine learning. When you talk about context windows, those do fill up. When you talk about retrieval augmented generation, a lot of times you're doing similarity search, so that's not really going to solve the problem. Another solution will be fine tuning, where it takes and understands these logs, where you pass in a few logs and you try to get some, analysis. The question I have for you, what problem are you trying to solve? Stop.
Where am I seeing drops? Where am I seeing errors? Basically, what's the state of my network? What do I need to know? And just kind of be able to ask that in natural language. I'm also thinking with AI, we're going to see a lower skilled workforce, and we're going to need tools that let just regular people, figure out the state of the network that don't probably have a network engineering background and can do that.
Let's answer the first question. So when it comes to analyzing which data center needs a thing. A lot of times you already have charts and dashboards for that. So rather than feeding it the entire data, maybe take a screenshot of the dashboards and compare them, and then let it analyze that part.
That's what I did, and it worked great.
Okay, there you go. Now your second question.
Well, I guess I was saying, I think with AI, we're going to start to see a lower skilled workforce because people aren't going to have to learn how to do this stuff, but then we definitely need tools that can answer questions kind of holistically and with detail. We need depth and breadth.
Yeah, that is a real problem, but I'm sure that was a problem with Google, that was a problem with Stack Overflow, that was a problem with Reddit. You all are the mentors, and so I think a good mentor should challenge those that they are mentoring to think. Because the skill isn't necessarily networking and knowing deep networking. They need to know how to think. They need to know where to go to find the problem. And so I think that needs to be like the thing to help people think. Rather than just going to the model, okay, go to the model, find a question, because you'll go to Google and do the same thing. But what are the questions you should be asking? What's the next question you should be asking? They really need to understand how to think. And so I think as mentors, we should challenge them to think. And so when they come back with the answer from the question that you ask them, how did they get that answer and why? We should always be asking why. If they can't answer why, then they have to figure out that. And if the model, to me, that's a form of learning. And once they apply it, that's a form of knowledge. Because through the repetition, being in the role, regardless if you Google it or not, the more times you have to solve a problem, the more knowledge you obtain. Now, the problem is working in the NOC, which was something I never enjoyed because everything was repetitive. I was in this box, and I could not log into a device and actually troubleshoot. I could just do show commands. So I don't know if I'm solving the problem or not. I got to escalate it to the people that can actually troubleshoot. So they need to have the ability to be able to take risk. Because a lot of times in network engineers, as a new network engineer, you may be handicapped, and it's hard to grow in an environment where you're handicapped. So we have to be in an environment where we're challenged and we take risks. And everybody doesn't want to be in an environment where they're challenged. They may say they do, but that's just the way it is. But those that want to be challenged and are willing to take the risk, we got to give them a chance.
Thank you for your talk. And then I have one question about how do you evaluate. So let's say you put the chatbot into production and ask how many regions, right? Like as a developer, you can see, okay, the returns 4, and you double check it's 4. Like in production, how do customer know that? How do they gain confidence about that's the correct result? Or like how do you guys evaluate during the testing phase?
So you can build, let's say you build a chatbot, you can build some type of human feedback where they rate the responses that are received, or you can use, like on Amazon Bedrock, we have model evaluation, where you use the samples test set to evaluate against those test sets. But you may create your human own test sets and you run the model in an automated way to where, let's say you ask this question 100 times and then you look at the results. And so that'll be your evaluation score to see how this model performs in your use case.
Got it, yeah. Thank you.
Yep.
I have a question. I'm sorry, I don't have a question. I
Yes.
just wanted to say I missed the first part of the talk. And I thought the way you presented AI at the end about the zones of, what is low risk, what is high risk, how to think about the 4 different quadrants that you put out, I think is probably the best I've heard about how to think about AI. So thank you.
No problem. Yeah, Chris was real patient with me. It took me a long time to actually put this together. I've been thinking about this for like a long, since I started generative AI. But to be able to come here and speak, I really do appreciate it. Thanks, Chris. Thanks, Scott, and the whole team.